and welcome everyone to the live stream of the introduction of JHipster and Kotlin, broadcasted live from home. This is another awesome session of the series BLD Tech Talks. We are all very excited to present you this session about JHipster and Kotlin. I will first introduce myself. My name is Leonie Huizing and I am an enthusiastic Java developer working for Capgemini. I have a passion for technique and innovation, and I'm honored and looking forward to be your host during this interesting event. Tonight, we will get introduced by two interesting technologies, JHipster and Kotlin. Starting off with an introductory session by Jacques de Wet about JHipster and with a live demo. Afterwards, Jan Mostert will tell you everything you need to know to getting started with Kotlin. If you have any questions during this live event, please feel free to ask them. You can write your questions in the chat. You can find this at the bottom of the live stream. When Jacques is finished, we will start the Q&A and he will be ready to answer all your questions. So, now it's time to start with the first part. Jacques, introduce yourself and start the journey to the introduction of JHipster.
Great. Well, good evening, everybody. And Leonie, thanks for that introduction. Yeah, as Leonie said, I will be introducing JHipster to you for those of you that don't know it, and for those of you that have heard about it and have never seen it before. We'll go through a short demo as well, and I'll tell you about the history about it and yeah, where we are now. So without further ado, let's get started. So first of all, this is the agenda for this evening. I'll just introduce myself, and then I'll tell you what is JHipster. I'll tell you a little bit about the history, the technology stack, both on the backend, the front-end deployment, as well as CICD. We'll be looking at some JHipster tooling. Then I'll give a hands-on demo. No technical talk is a proper technical talk without a live demo. And then we'll have some closing thoughts and some time for a Q&A session as well. So just to introduce myself, that's me with my lovely family, my two boys. I am from South Africa and at a little town called Somerset West. And if I switch over, I can, for those of you that don't know, I can show you where it is. So if we are here in the Netherlands and we zoom out all the way, fly across Africa, all the way down to South Africa. And if we zoom in, there's Cape Town coming into picture. That big bay there is called False Bay. It's known for all the great white sharks. And over there is a little town called Somerset West. And this is where we're from. And this is very close to Stellenbosch, which is quite well known for the wine region of South Africa. So that's where we're from. On a personal note, myself and my family love traveling. That's one of the reasons why we're here. I like to stay active, and I do a little bit of everything. That includes running, cycling, golf, tennis, skiing, and it looks like this season is looking to be a good season for skiing. So let's keep our fingers crossed for that. Let's just hope that Corona doesn't disrupt that. And then, of course, as you'll see later in the presentation, I also like rockets. So that's the theme for this evening, for this talk at least. And then just for fun, this is a picture of myself and a good mate of mine, Andre de Toy, who used to be my cycling buddy back in South Africa. And yeah, what you see there in the background is in fact blue sky. And if you look closely, those things are called mountains. So anyway, I thought that might be interesting to you as well. Anyway, on a professional level, I studied computer science and electronic engineering at the University of Stellenbosch. And at the moment, I'm a software engineer and solutions architect, aka problem solver at Capgemini. Throughout my career, I've worked in a few countries, and some of the highlights include Italy, where I worked at the European Gravitational Observatory, and the project was called Virgo. And the reason I mention that is because it's quite interesting. It's an experiment, the only experiment in Europe that do research on gravitational waves. And they in fact found gravitational waves a few years back. So that's a big accomplishment. Then I also did a short stint in Australia, spent a lot of time in South Africa working at various companies, and now I'm in the Netherlands. So what do I like about software? Well, I really enjoy how to get more done with less, and that's probably why I'm quite excited about JHipster. It's all about efficiency and productivity, and then obviously very important at the same time have fun. So that's my philosophy as far as that's concerned. Right, enough about myself. I think let's get to it. So I just want to set the scene in terms of the scope for tonight's talk. We'll really be just scratching the surface of it, or to put it another way, we'll be looking at the tip of the iceberg. I mean, the title says it all. It's an introductory session. So hopefully this will give you enough information to go poke around at your own time and yeah, experiment further with it. I hope I give you enough information to you that that you find it interesting, and then have a look at it by yourself. Right, so let's get started. What is JHipster? So for those of you that come from a web development background, you might be familiar with what a Yeoman generator is. That's often used to scaffold web applications. But what the guys did with JHipster is actually use that same concept, but instead of just scaffolding a web application, they scaffold a full-blown application, including the backend. And initially, this was created with Maven, Spring, and Angular. But over the years, this evolved really to become a development platform to basically generate, develop, and deploy modern web applications, and then also microservices. So what is the goal of JHipster? So this comes from the website, and I'm pretty much going to read it verbatim. Our goal is to generate a complete and modern web app or microservice architecture unifying a high-performance and robust server-side stack. So that's very important. It's got a big focus on the backend. Then also on the front end, it's got a focus on a sleek, modern, mobile-first UI with either Angular, React, or Vue, and then also using Bootstrap. It's not only an application generator anymore. It's now has become also a full-blown workflow companion tool. So you don't just scaffold your application and get started with it. You can use the tool throughout your development process. It's built on the front end using Webpack, and then on the back end either Maven or Gradle, which some of you might be familiar with. It has the option to generate a microservices architecture, and this includes keeping in mind cloud native principles. So obviously these days Kubernetes and that sort of thing are very hip. So it's modern in that regard. And then also it's leveraging infrastructure as code. So you can quickly deploy it to the cloud. So a little bit about the history, just to give you some context. JHipster is about 8 years old, and the reason I'm mentioning that is it's not a flash in the pan. It's been around for a while, and it's obviously gone through the growing pains and that sort of thing. So it's fairly stable now. The first release was made in 2013 with the 0.028 release. The current release is 7.4.1. So as you can see, it's been through a lot of incarnations. This I pulled from the website. It's used by 43,000 people. Now, I suspect it's probably more than that, but that gives you an indication of how broadly it's being used. And at the moment, there are over 620 contributors to that. So it's quite an active community. Right, let's have a look at what it consists of. At the back end, it is built on top of the Spring framework. It's leveraging Spring Boot. It's making use of Spring Security. It's including Spring Data. amongst other things. So very much comfortable with the Spring framework. It started off on top of Java, but now it also includes Kotlin. So later on, we'll hear a talk by Jan Mostert. We'll talk more about Kotlin. Kotlin is very hip these days as well. But some people in the community have also ported this to Node and also .NET, which is very interesting. On the backend, it's leveraging the build tool Maven or Gradle. On the persistence side, it supports relational databases through JPA and then also Liquibase. For NoSQL, it's got support for Couchbase, Mongo, Neo4j, and also Cassandra. It includes multiple cache technologies, including distributed caching technologies. It's got support for Kafka. It's got support for Elasticsearch. It's got built-in monitoring technologies. This includes the ELK stack. ELK stands for Elasticsearch, Logstash, and Kibana. And then obviously Prometheus and Grafana, which is leveraged off the Spring Actuator project. Also including testing frameworks on the backend, and then specifically for microservices, it includes Eureka, Consul, Zool, and Trafic, which is pretty much built on the code donated by Netflix, the Netflix open source software stack. So to continue to the front end, and I just want to put out a disclaimer there. I'm not a front end expert, so we're gonna not focus so much on the front end, but it has got support for Angular originally, and then later on when React and Vue became more popular, it also included support for those frameworks. It's built on TypeScript, which is modern. It's leveraging Webpack for the building of the front end, and also on the front end supports testing. If we look at the deployment support, it's obviously leveraging Docker and then also Kubernetes. And as I mentioned before, it's got support for deploying to multiple cloud providers, including AWS, Google Cloud, Azure, Spring Cloud, OpenShift, Heroku, and also Cloud Foundry. If we jump to support for CICD, it's got support for Jenkins, Travis, GitLab, CircleCI, Azure Pipelines, and GitHub Actions. Now, I haven't used all of those. I have used Jenkins, GitLab, and Azure Pipelines, but I believe the others are supported as well. So if we look at what's required for the development environment, it's actually not a lot. The only thing that you really need to pre-install is Java, obviously your JDK, and then also Node and NPM or Yarn if you prefer to use Yarn. And then what is optional is to have Docker installed. Some of the sort of like supporting tools are leveraging Docker. If you want to spin up a Prometheus server or Grafana or your databases for that matter. And then obviously you have the choice of what IDE you want to use. As I said before, it's leveraging Maven or Gradle on the backend, so IDE is not that important. But yeah, I mean, my IDE of choice is IntelliJ IDEA. So to look at the tooling, JHipster consists of a lot of tools. I think the most important one is obviously the CLI, the command line interface tool, which is something I'll show you. Then something that I leverage quite a lot is the JDL or the JHipster domain language, and this is specifically used to model your application, specifically your domain model. And there's also a JDL Studio for that, which I'll show you. So that then brings me to the next slide, which is pretty much to set the stage for the demo we're going to do tonight. So as I mentioned before, the theme for the evening is rockets. As you see there, that's a launch of the Falcon Heavy. And what we're going to be building tonight is a full stack application called Spaceflight. And I'll show you the domain model later. But this is what we're going to do. And I'm going to use that to show you the JHipster CLI. So I'm going to switch screens and present my terminal to you now. So I hope this is clear enough, but I've got JHipster pre-installed already. So if I go type in JHipster version. I'm not running the latest. I'm running 7.2.0, which doesn't matter. But what we're going to do now is we're going to create a full-blown application which consists of a backend as well as a front end. So let's get started. So how we do that is just type JHipster, and it's going to launch the application. And the first thing it's going to ask is whether you want to build a monolithic application or a gateway application or a microservices. So the gateway and microservices application is out of scope for tonight. So we're going to choose the monolith. And let's call it Space Flight. That's the name of the application. Do you want to make it reactive? Let's say no. It's got support for Spring for the reactive programming model, but we're not going to use that tonight. What is the default Java package name? Let's just say demo space flight. As I said before, it supports Spring Security. So you've got the option of either using JWT authentication or OAuth, and there it supports both Keycloak and Okta, or HTTP session authentication, which is stateful, but we're going to go with JWT, and then we're going to implement our security leveraging the database. So let's choose that. The next question is which database we want to run. So let's go for a SQL database in production. So we'll say SQL. I'm going to choose MySQL. It's going to ask us what we want to run for the development database. And let's make use of the H2 database with disk-based persistence. The next question is regarding the cache. And here you've got a few options: Caffeine, Hazelcast, Infinispan, Memcache, or Redis, or the option of no cache at all. But let's just, for the sake of this, choose EHCache for a local node, since we're running on a local machine. Do we want to make use of Hibernate second level cache? Yes, let's just choose the default. What build tool do you want to use, Maven or Gradle? I'm going to choose Maven. Then next question is, do you want to use the JHipster registry? In this case, also no. And then some of the options, as I mentioned before, do we want to include support for Elasticsearch, WebSockets, Apache Kafka, or API first development? I invite you to play around with this later, so I'm not going to choose any of this now. And then the option is for the front end. So all the previous questions relates to the backend. So what do we want to do for the front end? I'm quite a fan of Vue, so let's choose Vue. Do we want to generate the admin UI? Yes, we want to do that, and that's part of the demo later. The next question is, what theme do we want to use? Now, there are a few themes that you can look out on the Bootswatch webpage. I'm just going to go for the default one. And this is maybe a funky little facility as well. Do we want to support internationalization? And that's very easy to do, so let's choose yes. We want to do English by default, and since we're in the Netherlands, choose Dutch, and just for the fun of it, also choose French. This is the testing frameworks on the front end, which I'm, for the purpose of this presentation, just going to ignore. And then the last question is, would you like to install other generators? Now, I'm going to come back to this. I'm not going to install anything else, but I will refer later in this presentation, what other options there are in the marketplace as well. So what you're going to see now is if I press this button, it's going to scroll past with a whole bunch of line prints. And basically what it's going to do is it's going to scaffold our whole application. So let's see where the magic starts to happen. And there we go. Now, this might take a little bit of time. And for the sake of saving time, I'm going to switch over, because what I want to show you next is actually the JDL Studio that I referred to as well. So what we're going to build is we're going to build a silly little application consisting of the following domain objects. Let's call it a mission, the rocket, and the payload. And if I switch screens again, I want to show you what the studio looks like. So if I go back to this screen, this is the JDL Studio. And this is where you can actually design your domain model for your application. And it's very straightforward. It's got some syntax that you have to learn, but it's very easy. For those of you that are familiar with the UML, it might be familiar, but basically you create your entities, you give it a name, you give it a type, whether it's required or not. So in this case, just the mission, it's got a name, it's got a date. By the way, these are all Java types, and it's got a launch location. This is drawn for you. So if I, for example, type anything here, payload, let's say weight integer, it'll add it for you. So this happens on the fly, and it gives you a nice visual presentation of your domain model. It's got support for enumerations. So if we look at rocket type, those of you that are familiar with the SpaceX rockets, we've got Falcon 1. That's a duplicate, so that shouldn't be there. The Falcon 9 Block 4, Falcon 9 Block 5, and then the Falcon Heavy. Payload type, satellite or astronaut. And then this is used for where you model your relationships. So this is a one-to-many relationship from mission to payload. And this is a one-to-one relationship. And there's obviously support for many-to-many as well. So for those of you that are familiar with JPA or Hibernate, this should be all familiar. Some of the details further below, it's got the option to use DTO objects. Now, DTO stands for Data Transfer Objects. And it's leveraging a library called mapstruct. So you have the option to enable that, because otherwise your REST endpoints will just expose your entities directly. So I don't like doing that. So I like to use DTOs. And then if I use mapstruct, that means I don't have to do the mapping between the entities and the DTOs. And the reason for that is because I'm a little bit lazy. And then furthermore, I also prefer implementing implementation classes for the services. Now, these services are the Spring services. For those of you that are familiar with Spring, what it'll do is it'll generate an interface, but then also generate a separate interface class as well. So if we switch back, then I hope the backend has completed, and it did indeed. So if we just scroll back, what it did is it scaffolded the whole application for us, and also ran the build. And it looks like all of this was successful. And then it spits out some commands or some suggestions for you. If you want to run the application, you can just type that command. If you want to run the front end separately, you can just run npm start. Before I do that, I actually just want to switch to my IDE, and I'm going to drag it across to the other screen so you guys can see it better, because I want to actually show you what was created. So by just running that CLI earlier, what it actually created was this whole project for us. Again, for those of you that are familiar with the Spring application, this is a stock standard Spring application. If we dive into the source, you'll see main. There's a separate folder for Docker. So as you can see here, it's got built-in support for Prometheus, for Grafana. This is the Docker config for this particular app. And there's also support for MySQL, because we chose MySQL for the database, and then also SonarQube. Let's have a look at the structure of the app. We're not going to go into too much detail, but I just want to highlight this because it should be familiar to all of you. This contains all the Spring configuration. So if we look at the database configuration, stock standard configuration as far as Spring is concerned. So this is your database config. I'm not going to go through all of them. I think I'm just going to highlight some of the interesting ones. So this is your security configuration, which extends web security configurer adapter. If we drill down further, here's our domain model. Now, I haven't generated the domain model yet, but this is actually a backup of what I did earlier. So speaking from experience, you don't necessarily want to use all your live stuff, because if something goes wrong, your whole presentation is going to bomb out. So what I did before was I actually generated this application before. But this is then the domain model that was created. So there you see the mission, the payload, and the rocket. And these are stock standard JPA entities. If we drill down further, this is the repository. As I mentioned before, it's leveraging Spring data. So all it creates for you are the repositories. These are the security. This is the service layer. So I mentioned that we asked it to generate the interfaces for us, and these are then the implementation classes. So by default, what we asked it to do here is to generate a CRUD application for us. So the service layer implements all the CRUD operations on your domain entity. And then also, I just want to mention here, this is the DTOs that was created. And if you go to your REST endpoints, these classes will be used in your REST endpoints. For example, the mission resource, this is the API endpoint that exposes the mission domain entity. Great, so that's all on the back end. If we dive to the front end, then for those of you that are familiar with front-end development, this is a full-blown Vue application. By the way, we chose it to be a monolithic application, but in fact, what JHipster does, it generates for you a backend application and a front-end application which are completely decoupled, and it's communicating to each other via REST interface. So what we've done in the past and what I've done in the past is to generate a monolith, but then you have the option of creating a full-blown standalone front-end application and not leveraging the front-end that gets created by JHipster. It's still useful, and this is something that I'm going to show you now why I think it's useful. Anyway, we're not going to go into too much detail here, but this is the front-end application that gets created. So I'm going to switch back to what I've created before and just type this method. So what this is going to do is it comes bundled with the Maven wrapper. So you don't have to have Maven installed in your development machine. And what this is doing, it's compiling, building, and then in fact going to run our application. So let's just give that a couple of seconds. It shouldn't take too long. While we wait for that, nearly there we go. And we are, by default, we're running in dev mode, and it spits out the URL that we can use. So I'm going to just copy and paste that. And if I open up a browser, this is what gets created. So first of all, this is the landing page. And to access it, let's log in. And this just proves that the security is also working. So by default, it provisions 2 users for you. Very secure admin by default. And let's just get rid of these screens. This is then what you'll see. Now, homepage is just where we are now. I'm going to ignore the entities for now, but let's have a look at this tab. So only the admin user has access to this. But a few things that are interesting here is the user management. These are the 2 users that are created by default. If you want to create a new user, we've got a whole form that we can use to create new users. If we go to metrics, this is very useful. This is a page on the front end that leverages the Spring actuator on the back end to show you what's going on in your application. Again, I'm not going to go into too much detail here, but as you can see, it gives you some info about your system, memory, how many threads you're running, CPU usage. Of course, we're doing nothing now, so you don't even see that. We've got HTTP requests. You can see what the count is for all your endpoints that you're hitting. We haven't exercised this yet, so this is why this is low. Gives you information about your cache statistics, and then also about your data source. So very useful as far as I'm concerned. By the way, this is leveraging Spring actuators. So this is also the endpoint that gets exposed if you use Prometheus. That'll get scraped and pulled into Prometheus at a later stage as well. The other thing that's very interesting is we've got the logs. This is where you can switch on and off dynamic logging. The API, very, very useful. This is built-in Swagger support for your API that you created, for those of you that are familiar with that. And then also the database. This stage, it's just using the built-in H2 database, so we're not going to use that now. What I want to show you here is also the support for the language. We've got, if we switch to Dutch, the whole application changes. If we switch to French, there we go. Very funky. And let's switch back to English. What I want to show you as well, we've created entities now, and what JHipster does is it creates a full-blown CRUD application for you. So once you create the entities, you can already see them here, and it's configured to seed your database with data. So that's why this is populated now. Yeah, you have the option to switch that off, but what you see here are all the entities. It's got the CRUD functionality for you. So in other words, the full list. We can view them, we can edit them, and obviously delete them. I'm not going to do that now, but let's go for maybe the rocket or what was the other one? The payload that I wanted to show you. So if we edit, for example, the payload, we can choose which mission the payload belongs to and then save it, and there you go. So a full-blown application generated in literally, what, how many minutes was that? 5 or 10? I'm not sure. But anyway, as you can see, quite useful. So I'm going to switch back to the presentation mode because that was what I wanted to show you as far as the demo is concerned. So let's just quickly talk about then, what is under the iceberg that I didn't show you. As I mentioned before, JHipster also supports microservices, which is originally based on the Netflix OSS stack. And in fact, that's probably more powerful than what I showed you now. So I really invite you to have a look at the support specifically for microservices. The last question you saw when we ran through that CLI was whether we want to enable modules or blueprints. Now, this is something I can maybe switch to as well. As I mentioned, the community is quite huge, and there are a lot of other contributors that also created, let's call it plugins for JHipster. I named a few here. For example, there's support for Ionic. There's support for React Native. For those of you guys that are interested in Quarkus or Micronaut, there's even support for that. I mentioned in the beginning, you don't have to use Java. There's support for Kotlin as well, so you can generate your application using Kotlin. I think I might just actually take some time to flip over to the JHipster page. And if we go to modules and blueprints, these are the official blueprints. As I mentioned, Kotlin, Vue, we saw the Vue one. This is the one I was showing you. .NET, Node.js, Micronaut, Quarkus. And then in the marketplace, there are quite a big load of different plugins that you can try out. I've used some of them some of them before in the past, but have a look. It's quite an extensive list. So yeah, other tips and tricks from my experience. As far as I'm concerned, the JHipster tool is quite flexible. So it's one of those tools that don't prescribe only one way to do things. It's quite flexible in the sense that you can sort of like pick and choose what you want to use. What I demonstrated now was a monolithic app, but as I said, you still have the option to, for example, not use the front end and then create your own front end. And this is something that we've done in the past. But in the end, it's just a Spring application. So you can generate your application and then ask JHipster to step out of the way and take it further from there. So from that point of view, I find it very flexible. So you're not in and then you're tied to JHipster. Although they have the option to sort of like walk with you as you develop, but you're not tied into it. So it's not one of those tools that you hooked and then you can't get rid of it. Then for some closing or final thoughts from my side. Technology, as far as I'm concerned, is evolving at quite a rapid pace. And a couple of years ago, CRUD was sort of like the sort of like the architectural choice that people made. These days, things are changing. People are switching to microservices architecture. Event streaming and event sourcing are becoming more popular. At this stage, JHipster very much supports the CRUD model. Now, in a lot of cases, this might work for you, but not in all cases. So keep that in mind when you make a decision. What do you want to, what your application will be like. I think the point I want to make is this is not the only tool out there, and think about what you want to use, but it is quite a useful tool. So bear that in mind. And then I want to close off by just leaving you with some reference material. I don't know if we'll be sharing this slide deck later, but otherwise, please have a look at the JHipster website. They even have some official slides on their side, which are much more thorough than what I showed you tonight. Have a look at the blueprints. Those are very interesting, and I think this is where a lot of future activity will be. And then also the marketplace, which we touched on briefly. And we are on 40 minutes now, so that's not bad timing, I guess, from our side. I want to close by saying thank you to all of you. If you want to reach out, please find me on LinkedIn. This is my LinkedIn profile. And if you have any questions or comments, please put them in the comment section, and I'll be happy to answer you. Thank you.
Well, thank you, Jacques, for the clear explanation. And so nice to see that we have viewers all over the world. So hello, Amsterdam and South Africa and Germany and Saudi Arabia. Wow, fantastic.
Wow, a full-on international audience.
Yeah, great. Indeed. And sorry, Jacques, but because it's all over the news, what type of logging is JHipster use?
What type of logging? I give you one chance to take a guess, Leonie. But it's using Log4j, and I must be honest, I haven't had a chance to look what version of Log4j they're using, but I'd be very sure that they will patch this very quickly. But as I mentioned before, you don't have to rely on the JHipster team to fix this. You can dive right in. It's a Maven or Gradle application, and you can update your own dependencies. So it shouldn't be a problem.
Good to hear. And in your presentation, I see that you are a fan of space. And in your application, you mentioned a number of rocket types, including the Falcon Heavy. And Elon Musk is already working on some private flight to space. Do you have any ambition to fly maybe with the Falcon Heavy or the Falcon 9 to space?
Oh, well, if you talk about ambition, let's put it like that. I'd rather choose going up with one of the Falcon rockets than the Blue Origin rockets. I think a 3-day trip in space is much better than a 11-minute trip to the Kármán line. But at this stage, yeah, I don't know what the pricing is for the flights on Crew Dragon. But if I get invited, for sure, I'd be the first to say yes. So Leonie, I don't know if you have context. I mean, Elon Musk is an ex-South African, but yeah, I haven't received any invite yet. So if you've got context, please let me know.
Well, maybe he's watching now, and we will see you. That's another question. JHipster sounds like a very magic framework that can do everything. So are there any reasons why we shouldn't use JHipster?
I think I touched on that before. Yeah, as I mentioned, technology is changing quite a lot, and if the problem you want to solve is not suited to what JHipster offer, then don't force it. I also mentioned it's quite flexible. So what I showed you now are the features that I think are interesting. But if you, for example, have an application that's not leveraging a database, it's not only a CRUD application. So by all means, you can leverage JHipster to generate the microservices for you, which, for example, don't talk to a database, where you just, for example, plug into Kafka or something else. So it's quite. I think it's got a broad area of what it can do. Something that I haven't seen yet is where they're addressing the event sourcing or event streaming kind of applications. But in a way, they have support for Kafka, so there's no reason why you can't sort of like tweak it to fit that model. So again, I mean, it's not a yes or no question. Think about what you need and then evaluate whether it fits your requirements, and then take the plunge.
Yeah, sounds like some good advice. And maybe some other question. Would you recommend to use JHipster only when building an application from scratch, or can you also use JHipster in an existing application?
No, that's going to be difficult. I think it's a lot easier to start, on a new application and use it, and then if you want get rid of it, I think it's going to be very difficult to introduce JHipster when you have an existing application. In fact, I think it will be almost impossible. So purely because of the conventions that they use, which are not far removed from the best practices, but it's going to be difficult.
Okay. Let me check in the chat if I see some other questions.
But the only on that question, maybe one comment I can make on that point is, for example, if you have a backend API that are already exposing Swagger, for example, nothing prevents you from generating the front-end application by leveraging the Swagger API. So that's also an option. So depending on what you want to do, you can use it.
Yeah, good point. I see we have a question in the chat. It's from Pierre. Nice, Jacques. Can JHipster do a domain-driven design too, or is it up to the builder to add an app and infra module?
I'm not entirely sure I understand the question, but let me just read it again. Can do a domain-driven design. What I demonstrated here was pretty much a domain-driven design, although I went through it very quickly. We modeled the domain model, and then we scaffolded the application with it. As I said before, you don't have to just use JHipster at the start. As your application evolves, you can update your application with it. And I've certainly used that in the past, where the domain model grows and you add to it, and then you enhance your application with it. So I would say, Pierre, yes, very much so. And I think this is where the JHipster Studio comes in very handy, because you can model your application visually instead of writing code, which makes it a lot easier to understand and communicate about it, and share with your colleagues.
Yeah, well, sounds like a good feature of JHipster. I think that were all the questions. So thank you, Jacques, for answering all the questions, and thank you, watchers, for being with us and asking all those good questions. I think that it's now time for the second part, and that's with Jan. So please, Jan, introduce yourself and then start the journey to the introduction of Kotlin.
Good evening, everyone. Sorry, just having some technical difficulties. Okay, imagine a time. I'm just going to slide share. Okay, this thing just stopped working. Okay, imagine a time. Back in the days, many years ago. This is not working. Okay, I'm just going to stop sharing and reshare my screen. Okay, is that working? Okay. Okay, imagine for a moment a time in history where the concept of zero does not exist. Over 2,000 years ago, that was the reality. Subtracting a number from another number itself had no meaning. There was no symbol to represent the absence of a number, and over the time as mathematics evolved, the concept of zero emerged. And it was often just represented as a value, as an absence of a value, as shown in these Chinese, what do you call it? It was absent of it, often just showed as a space in these Chinese counting rods. Historical records show that zero was written as a number, was used as early as the 5th century. So in India, just like with any brilliant idea, it quickly spread across the world and was eventually incorporated in numerical systems, while algebra for its use was developed like what multiplying or dividing by zero means, what subtracting or adding, and later on techniques to deal with the edge cases like dividing by zero, multiplying by zero, etc. Okay, then in 1965, we saw a repeat of this whole zero saga, only this time in programming. So imagine a programming language without null. I mean, to most people, that sounds absurd. And prior to 1965, there was a time when null still didn't exist. 1965, Professor Charles Anthony Richard Orr, who invented the quicksort and won a Nobel Prize for computing, was most likely sitting behind his computer and sipping on some cola and thinking by himself, how can I over-engineer this code in front of me? But how can I resist the temptation to put a null reference simply because it's so easy to implement? And this was later known as the billion-dollar mistake. It was the invention of the null reference in 1965. And at that time, Anthony Orr was developing the first comprehensive type system for an object-oriented system in Algol W, which was later the basis of Pascal. And his goal was to ensure that with the introduction of null, that it was absolutely safe. But null in most type systems weren't safe, and this led to innumerable vulnerabilities, system crashes, and which have probably caused $1 billion in issues in the industry. Yeah, but was it really a mistake? Let's find out. I mean, there's nothing inherently wrong with null, but most languages until now simply just did not model it correctly. So, I mean, JavaScript made it even worse. They introduced undefined as well. So you can have null, undefined, also zero, which in some cases I'll show that's also interpreted as null. And then you've got no value. Standard equality checks does automatic casting in JavaScript. So, for example, this is the perfect way to do it in most systems. But since most companies used linting tools that force you to use triple equality checks, you are kind of forced to do a null check or not undefined checked. And then since developers don't often know JavaScript properly or they're lazy, they do the third option, so if A, which often leads to bizarre bugs. So for example, if A is 0, this would be a false statement and this would not execute. How does JavaScript handle the absence of a value, of a value? So in ES6, at least, there's the null coalesce operator, which allows you to first check, is it null? If it's null, default to some other value. And then also ES6 introduced the null check, basically, which makes life better. I mean, this is both TypeScript and JavaScript. It makes life better, but it's not enforced. So if you don't have a linting system that checks for this, this simply doesn't happen. And eventually you run into an uncaught type error like the one shown here. What about Java? I mean, Java's got a much saner type system. And in Java, you're often forced to do lots of null checks manually, like this. And if you forget your null check, you often run into a null pointer exception. Same bug. That's a company did an analysis in 2018 where they marked the number of crashes by exception type. And null pointer exceptions were right at the top of it. It was twice as many as runtime exceptions, which were twice as many as IO exceptions. And then since JDK 6, various entities tried to solve the problem by inventing their own @NotNull annotations. So I don't know if you can see here, but if you look at some of the code that's published by JetBrains, they check for @NotNull annotations by JetBrains themselves. They've got SonarQube. There's one by RxJava. There's the Lombok @NotNull annotation. NetBeans introduced their own one. Eclipse introduced their own one. SonarQube introduced their own one. Android has got their own @NotNull annotations. And then JS R305 tried to unify the standards. And you know what happens when you try to unify the standards? So here's some mandatory XKCD tags. There are 14 competing not null annotations. Ridiculous. We need to develop one universal standard that covers everyone's use cases. And the result is you now have 15 competing standards. So, I mean, probably somewhere out there, there's code that has 15 different types of not null annotations, and it will still throw a null pointer exception in some system somewhere. If you do see such a thing, please send me a screenshot of it. It would be very funny. Some in JDK 8, Java introduced a thing called optional. And the funny thing about optional is it can still throw a null pointer exception. And also your code becomes very unreadable. So, I mean, if you look at the above example, it's not very clear what exactly is happening here. Now compare this with Kotlin code, Dart code, TypeScript code, where you can just do an optional null check and then default it to some value. I mean, it reads a lot better than, a lot easier than the Java code. Okay, let's go back in history again, about 50 years ago. So Algol introduced what is called tagged unions. Tagged unions allows you to have multiple types per variable. So I'm showing a TypeScript example here where the type is both number and Boolean at the same time. So if it's number, if it's type number, do something, and if it's type Boolean, do something different. Then in 2011, Red Hat unleashed yet another JVM language onto the world. It's called Salon. The top type in the Salon type hierarchy is called anything. So anything contains two subclasses: object, which is the superclass of classes and interfaces, and then there is null, which only contains the value null. Since object and null are separate types, anything that's null can only contain the value null, and anything that is not part of the null class or the null set cannot contain null. So, I mean, that would be like assigning a number to a Boolean. It just won't work. And then if you do a bit of Boolean algebra, so for example, object or null, and then you do a null check to see that is not null, then you'll have a non-nullable object. So by defining null in the type system as a separate set, and using the union of object and null, this is exactly how you solve the billion dollar problem. And this is exactly what Kotlin did. So in Kotlin, you have type with a question mark, and type with a question mark is basically type or null. So this type is nullable, and in Java, you would annotate it with @nullable. And then type without a question mark is a non-nullable type. And then Kotlin introduced the third type. So since Kotlin has to operate or interop with many platforms, which doesn't take null seriously or null safety seriously, you've got the, I call it the Schrödinger type, but it's actually called a platform type because it can be null or it's maybe null. You don't know. But Kotlin offers you three modes or three ways to handle this. Either you can do strict mode. Strict mode basically says you always have to do a null check on the platform types. In which case it won't compile unless you do a null check. And then the second option is only to give you a warning if you try and access something which might be null. So then your code already becomes a bit shaky. And then there's YOLO mode, which basically says do whatever you want. This is like Java. You just throw a null pointer exception if you hit anything that's accidentally null. Okay, well, null safety across platforms is already a brilliant feature. Let's quickly run through some of the other brilliant Kotlin features before digging into multi-platform itself. JavaScript and TypeScript allows you to make the use of prototypes, so you can kind of extend anything you want. So, for example, in this example, I extend the string object to allow you to call hello on it, and it would do something. Java doesn't allow you to do extension functions, so you're kind of stuck with Apache Commons and all these util classes littering your code base. In Kotlin, it's pretty simple as well. It's just string.hello, and you're done. Just like Python, Kotlin allows you to override operators. I mean, you can override anything. If you can't use an operator in some class, you can even create it. So, I mean, unlike Scala, which allows you to create any operator with symbols, Kotlin decided that it'd be safer if you can only create operators that are similar to function names. So, for example, in this example, I'm overwriting big decimal plus integer. So if I say big decimal plus 1, it will actually compile and return something. So in the code I'm overwriting here at the top, it says big decimal, and then it creates a new instance of big decimal, and it actually executes it. Similar, big decimal plus, I can overload it with double, so then I can just plus a double, and the same with string. So I can just plus 2.0 in quotes, and it'll work. And then the infix operator allows you to create, as I said earlier, your own operators. So I've invented the YOLO operator here, which says big decimal YOLO 3.0. I don't know what it's doing, but I mean, you can do that. Typically infix is used for in the standard library for stuff like XOR and Boolean operators. You also see it often in DSLs. People write their own DSLs to be more natural language-like. JavaScript and TypeScript add string literals or string templates since ECMAScript 6. So you can do backtick, define your string templates, and then just $curly brace your variables directly into it. Kotlin is exactly the same. You can, except the difference is you have to use triple double quote, and you can also use dollar variable or $curly brace variable. And Java 15 finally caught up, and it has also string templates, but or string blocks. But unlike Kotlin and JavaScript, you're kind of stuck with string.format if you want to put values into it. I mean, it gets the job done, but it's not there yet. Kotlin opted for property access instead of putting getters and setters all over the place. This actually makes it easier or makes the code cleaner. So, except in Java code, you'll often see classes with lots of getters and setters, which basically just expose a private value. In Kotlin, it's a property by default, and then if you do want to override the getter and setter, you can also do that. And by overwriting the getter and setter, you don't actually change the API for your class. Kotlin has named arguments, which allows you to either send, you can either call a function with the normal parameters like in order, or you can call it in any order by just naming them. And you can even put default parameters on some of these arguments, allowing you to even skip some of them. So for example, if the first name was by default Pete, and I don't supply the first name here, it will default to Pete by default. Kotlin also has composition over inheritance. It just makes it a lot easier to implement delegation. It has some built-in delegation patterns like lazy. It has some observable properties. You can also delegate getters and setters to another instance. So typical use cases when you have a class that wraps another class and want to delegate getters and setters to a wrapped class. I've personally built a dependency injection framework using delegation. So, I mean, it's pretty nice. There's also smart casting, which basically gives a bit of common sense to the compiler. So if I know this thing is a string, because I just assigned a string to a variable, it's going to be a string. The compiler will know it's a string. If I've just done a null check on this, the compiler will say, oh, you've just done a null check on this. You don't have to do a null check on this again because I'm smart casting it to a non-nullable. Type inference. So Kotlin, you don't have to, I mean, Java's recently got that as well to some degree. But in Kotlin, type inference is pretty potent. So you just assign something to something else, and the type is automatically inferred for you. I mean, it does reduce boilerplate code. Inline functions. So inline functions allows you to inline certain blocks of code. I mean, this is typically used in reified functions. So when you compile generics in Java, it strips your types out. Kotlin allows you to inline those functions and then use reified generics. So you can, that type T that gets compiled out on Java, you can still access in Kotlin. Immutable collections, this is a brilliant feature. It allows you to create collections, lists, arrays, sets, whatever, that are immutable. So one of the best practices in Java is to do defensive copying. So if you send a list to somebody, you have to defensive copy it in case that thing gets changed. Since Kotlin lists can be immutable, or they're immutable by default, unless you specifically say they're immutable, you don't have to do that defensive copying because the list can't change. Standard library, I mean, this is a brilliant feature of Kotlin as well. So it's got all the nuts and bolts you need to build a lot of stuff out of the box. So you don't need util libraries for JavaScript and Java applications. Well, most of those things are already built into the standard library. Coroutines, I mean, that's a talk on its own. Serialization and multi-platform is what I'm going to get to today. I mean, as demonstrated, the Kotlin language is null safe. It has implemented all the very easy ways to implement all the best Java practices without a boilerplate. It's quite a modern and heap language as well. Coroutines, which is a structured concurrency to help you do concurrency in a consistent, predictable manner across platforms. But what problem does Kotlin multi-platform actually solve? Okay, so let's have a look at large applications. So this might be a Fortune 500 company, a Fortune 100 company, might be a startup. So let's see. Most companies have a database and at least a backend. And the backends are typically Java, C#, or any other kind of backend language. Some companies still create desktop applications. I mean, I've seen companies still using Delphi. If this is a business desktop application in a Java space, sorry, you might expect something like JavaFX in here. And if you're doing some native application, you could be looking at Objective-C or Swift for Apple devices, or you could be looking at C++, Qt, or Python and GTK for your desktop application. If you introduce a web application to the stack now as well, you get to actually choose a lot of different things. So which build system do you use? Which framework do you use? Do you use React or Angular or Vue or Ember or Meteor or Mithril or Polymer or Relia, Lit Element, Micro HTML? So let's assume most large organizations have at least one or more web applications that are actively maintained, and they're often in different languages. So one might be JavaScript, the other one might be TypeScript, and the other one might be in Dart. So yes. And now if you start adding mobile applications to the mix, your stack gets pretty complicated as well. Okay, let's add a bit of color to this. Yeah, let's bring this to reality. So let's say, for example, this large organization has a backend application in Java and Spring. It has another application in Rust. I mean, maybe it's doing some kind of photo or video editing or processing that needs a bit more oomph. Then they've got a desktop application built in C#.NET, another one in Swift, and another one built in C++. And in the web space, they've got a TypeScript with React, JavaScript with Angular, and let's say, or Dart and Vue. For Android, they've got Kotlin, and for iOS, they've got Swift. I mean, that is a huge variety of languages, and you'll typically have a separate team for each of these. And then in between, you might have something like Swagger to generate, generate certain things that can be used across these platforms. But I mean, does that really solve the issue? If you want to, I mean, if I want to change, let's go back quickly there. If management asks you to implement a small feature, let's say you want to change validation on certain things or on some input, what's going to happen? The backend developers will have to implement it on the backend. Your database admin will have to implement a specific feature in the database. Your .NET team will have to go and duplicate that logic on the Windows desktop. Your Swift team will have to duplicate that logic on Mac OS. Your desktop Linux guys will have to implement that as well. And then on the web space, each web application will have to go and duplicate that logic as well. And the same goes for Android and Swift on iOS. I mean, what if one person could write that business logic or make that change in one place, write a test case for it, and then simply allow each team to publish an update instead of duplicating that business logic across all the spaces. And this is certainly really possible. So in order to do that, you have to build the whole platform in a single language or use a language that can transpile to the other languages. So JavaScript, you can do that with Node.js, Electron for the desktop. Your web is obviously already covered, and you've got Cordova, PhoneGap, and some of the other frameworks here. The issue with this is your Electron application is very heavy, since it's basically a browser that's packaged into a window. And on the server side, you've got a single-threaded application. And for specific use cases, single-threaded is just not going to cut it. And I was going to make a joke about JavaScript being vulnerable in the backend, but then Log4j happened in the Java world as well, so I'll keep quiet about that. What if we built the whole thing in Dart? So since Dart 2.12, you had null safety in the language as well. The only issue with Dart is that the backend frameworks are all kind of abandoned. So Angel, Conduit, these other ones are not really maintained anymore. If you were stuck in Angular Dart, I see Google just published a couple of months ago that Angular Dart is in maintenance mode, so they're not doing any further big maintenance on Angular Dart. And then on the desktop and web, you can use Flutter. And one never knows if that's going to go the same route as Angular Dart. It might not. So it's a gamble you've got to take. Is it possible to build the whole thing in Java? On the back end, Java is certainly a good option. So especially combined with Vertex, you're obviously going to get one of the fastest backend applications. On on a web front, GWT is still around. I believe J2CL would be underpinning GWT3. I'm not exactly sure how well that project is maintained. And for desktop, I've looked at JavaFX. It seems to cover all the bases there. And then for mobile, Android, you covered. I'm not sure about iOS. I Googled a bit around and saw there's a project called Codename 1. I don't know much more than that. Okay, and then in the C# world, this is also possible, also with some limitations. I'm not sure if the Linux desktop is fully supported. On C#, you also have the benefit of Unity. Unity gives you the benefit to generate WebGL. So, I mean, there might be some advantages on the C# platform. Let's get to Kotlin. So on the Kotlin space, any Java backend you use will also be compatible with Kotlin. So you could use Spring, you could use Vertex. Vertex even has a Kotlin flavor if you want to go that route. Then there's Ktor. Ktor was built by JetBrains themselves, also maintained by them, and that is also my preferred framework for Kotlin backend development. For desktop, you could go the native route, Kotlin native. Or there's also TornadoFX. Android and iOS, there's Kotlin Mobile Multi-Platform, which allows you to share your Kotlin code between your backend and your front ends. And then on the Kotlin JS space, there's a Kotlin React thing that is built by JetBrains as well, also maintained by them. And then there's a pure Kotlin framework called Fritz2. So for those people who don't want to go and mix Kotlin and JavaScript, you can just write the whole thing in pure Kotlin. So for the purest amongst the people. So, I mean, Kotlin platform is designed around the ability to write some common code that can be transpiled to JavaScript as TypeScript and using Kotlin JS, JVM bytecode using Kotlin JVM, and then native code for iOS, Windows, Linux, macOS, both Intel and ARM, watchOS, tvOS, Raspberry Pi, and recently they also added support for WebAssembly. I'm not sure how mature that is yet, but that's also out there. Let's have a look at a practical example. So I prepared a code sample here. Okay, let me just stop sharing. Okay, so first things first. Over the weekend, I've built a server application, very simple server application in Ktor. Since I didn't have a lot of time, I also slapped something together last night in JavaFX or TornadoFX. And then on the JavaScript side for the web front, I built something in TypeScript, micro HTML, and ESBuild. So ESBuild is supposedly, well, from my own experience so far, I've seen it is much faster than Yarn and Webpack and all these other ones. So let's have a look at what I've done here. Okay, so I'm going to start up the server. And just like with any good demo, it's taking its time. Okay, so server is started up. I've started a web client on this side on ESBuild, and then let's start a desktop client as well. Okay, so the desktop client is nothing fancy here. I can add an extra lesson. So the project I've built is called Things I've Learned Today. Okay, so this JavaFX or TornadoFX thing is just for demonstration purposes as the second platform, so I'm not going to dig too much into that. But let's jump to what it looks like the JavaScript side. Okay, so the one I've just added on the Java FX side is appearing on the web front end. I can add a couple more, and this thing is limited to only allowing you to add 3 more things I've learned today. So let's have a look at how this is built. Okay, so what I've mentioned earlier is that the ideal way to build such an application is to have a common module. Okay, so my common module has a common main, and in the common main, I've got a state. As you can see, I'm exporting the state into JavaScript. And since this is in the common main, it'll get compiled to each platform that I'm supporting. So if we have a look at index.typescript, you'll see this thing gets generated. It gets compiled to JavaScript, and it generates some nice TypeScript headers for you. So whenever I change something in the state here, okay, and let's put that back on. The Gradle build -t basically runs in the background. So whenever you make any changes, it automatically gets compiled. I'll demonstrate that in a bit as well. So as you change your Kotlin code, your JavaScript code gets updated automatically. So you can just refresh something without going through the long build process again. Okay, let's give it a couple more seconds. And voila, there's the blah I've just added in the Kotlin code appearing in my TypeScript header. So if I delete that again, it should be a lot faster. And it's gone. Okay, so there's 2 different ways to implement things in Kotlin multi-platform. So this is the one way where you've got a module or a class that is compiled to different platforms. Then there's also, in the case if you want to do a HTTP call. So what you're doing in JavaScript is not exactly the same as you're doing in Java. So let's have a look at, for example, action as an expect clause in front of it. So this basically says the common class or the class action expects an implementation for both JavaScript and for JavaScript, for Java and JavaScript. So in this example, the Java one implements standard HTTP call with Java code. And if you go to the JavaScript one, you'll see that it is using window.fetch instead of the network request that's being done in Java. Yes, and then somebody at the back is screaming at me, but you can already do this with Swagger. And then I'm saying, well, yes, Swagger can do some of it, but can you do this with Swagger? Can you generate rules that can be applied to your front-end, back-end, mobile, and web at the same time? So I've implemented a simple rule here called a lesson limit. So let's go back there. You'll see this is not going to allow me to add any more. So let's increase that limit to 4 or 5. Give it a few seconds to build again. Now I should be able to add more lessons to it. I think I'm getting an error here. Oh yes, I've got to restart the backend. Since this rule is also applied to the backend, so you can't do a JSON post from outside to bypass the rules that says how many of these things I've learned today you can have. Still starting up. Oh yes. String gets wiped every time you restart. Okay, so now you can add up to 5 items, and if I restart the desktop application, you'll also be able to, well, you won't be able to add more because there's already 5 of them. Yeah. Any questions?
So, hi Jan, thank you. And wow, you know so many platforms. How do you get all that knowledge about those different platforms?
I code every day, so coding is a hobby for me. So besides the scuba diving and mountain biking, I also code. I try to get in a couple of hours a day of just building random stuff and exploring new stuff, and yeah.
Nice. And what would your advice be to the organization that have that all that uses of the different platforms? Only use Kotlin?
I mean, if it's an existing organization with all that stuff, I mean, that's called technical debt. They've got to maintain that. They've got to maintain teams to keep all that stuff going. But if you're starting a new project from scratch, I mean, I would not recommend going that route. I'd say build the whole thing on Kotlin, and your life is going to be easier. I mean, if you're only going to build a backend application, a web application, JHipster might be fine. But if you've got to support desktop and web as well, as WatchOS and Raspberry Pi, etc., I mean, I would go and say, well, build the whole thing in Kotlin and compile it for all the platforms.
Okay. Is Delphi, is that the framework?
Delphi is very ancient. I mean, it's back in the days when Pascal came out.
So it's before my time.
Yes, but there's still companies using Delphi desktop.
Okay. And Spring is a widely used framework in combination with Java. And
yes.
which framework is commonly used in combination with Kotlin, or does Kotlin not need a framework?
Personally, I don't think it needs a framework. I mean, many people do put Spring in there, but I personally just write my own thing or put Ktor in there, and it works fine.
Okay.
I mean, if you use the Spring, by all means, put it in the backend. It works fine. I mean, Spring and JetBrains, they actually collaborate to make sure stuff works together.
Okay. That's good news, I think. I'm not sure, but is there a Pokemon next to you?
Yes, Snorlax.
Snorlax. So you're a fan of Pokemon?
So back in 2018, I saw this in the shop in the Netherlands. So we were visiting in the Netherlands, and I saw it in the shop, and I bought it, and now I brought it back to the Netherlands.
He's cute. Okay, so let me check if there are any questions in the chat. No, I think not. Well, then thank you for joining us in this awesome build tech talk about JHipster and Kotlin.
I see a comment there about GWT. Yes, GWT used to be awesome, and I wish they supported Kotlin. That would be awesome, but yeah.
I see. There's also a Pokemon fan. Snorlax is the best.
I mean, you don't need GWT anymore because of Kotlin JS. If you're writing Java code, I mean, GWT still works.
Was that answering your question, Pierre?
I think that was more a statement.
Okay. All right. Oh, nice talk, Jan, Mark said. Well, I think it was a very interesting talk, and you did a nice job, Jan. Thank you so much. So then it's almost time to finish. I would like to thank you, Jan, and Jacques, for your valuable contribution. And if you would like to be in contact with one of our speakers, you can contact them via LinkedIn. But I'm not sure, Jan, do you have LinkedIn?
I do, but I haven't updated it in quite a while.
So if people want to be in contact with you, how could they reach you?
I think get in touch with Leonie, and then she can forward.
That's also fine. We will put our LinkedIn in the chat, and if you like to reach out to us, you can find the link in the chat. And there's only one thing left for me to say, that is thank you very much for joining this Tech Talk, and we'll see you next time as well. Bye-bye.
Bye-bye.